So in last class, we have seen how to perform the partial abstraction. Okay, so with the help of abstract class, so if you take abstract class here, few methods we have implemented. For few methods, the logic we already implemented. For few methods, the logic we didn't implement. Okay, in the abstract class. Okay, this is called partial abstraction. Okay, so here, whatever the rules applicable for class, all rules will be applicable for this abstract class, but only the difference is you cannot create the object. You cannot create object. So you can, if you want, you can write a constructor also. Suppose if you want to write some constructor, you can write the constructor, your own constructor, but still you cannot directly call this constructor. Okay, but suppose if we have so why we are using constructor? So constructor we use for to initialize the values. To initialize the values, we can use the constructor, right? So that we have seen in chaining of methods also. Let me open that. Chaining of methods. Okay, in personal details class and also professional details, I think so. Yeah. See, this is the constructor we have written to initialize the global values, global variables. Okay, that can be primitive variables, I mean primitive data type, or that can be any reference data type. Okay, so similarly, you can also create constructor, and if you have any global variables, you can assign values to the global variables. Okay, so suppose string some name that you want to assign. If you want to assign some name to the string through constructor, yes, you can assign while creating the object for this class. But the problem here is you cannot create the object for abstract class. Then how I can call this constructor? How I can call this constructor? Okay, so let me go to implementation class. Okay, here, see, whenever we created the constructor inside the abstract class, what it is asking, that constructor you have to implement in your child class. Okay, so let me add it. See, so in with your child class, you have to implement it, which means if you want to create the object, for your implementation abstract class, or if you want to again extend the implementation abstract class in your provide access class, again you have to add constructor. Okay, so here if you want to call methods of implementation class, when you are creating the object for your child class, you have to pass that argument, name argument. Okay, so but if you look at here, it doesn't contain, it has the constructor. Okay, so it is also accepting one parameter, but with that parameter you are calling the superclass constructor. Okay, using super keyword we can call the superclass constructor. Again, if you go to superclass, so here when you are calling constructor of your superclass with some parameter, inside that again it is calling its superclass. Okay, what is its superclass? It is a abstract calculations class. Okay, so which means, okay, here you are initializing the value, which means you can send any object. If you want to send any object through the constructor to some other class, generally we use the constructor. If you want to runtime, if you want to pass some object to some class, that technically we call it as dependency injection. You have to pass that argument. You have to create the object and you have to pass the argument. So using abstract class, okay, so the same thing, like whatever we do in the class, the same thing we can do with the abstract class also. But one thing is we cannot create the object. Okay, so if you want to access this class methods, so you have to extend this class to some other child class. So inside that you have to implement the methods. Okay, whatever the methods were not implemented in the parent class, those methods you have to implement. Okay, so this data you can hide, and for your child class you can create again here you will create it as a public class. This implementation class will not be a public. The entire data you will hide here through the intermediate class. Okay, the similarly how we are performing partial abstraction, the similar way if we want to perform the full abstraction. Okay, if you want to perform the full abstraction, we have interfaces. Okay, so from here interfaces concept will be started. So if you take the general meaning of interface, what is interface? Okay, so suppose if you open some browser, that is one interface. So you opened one IDE, this IDE, this is also one interface, right? This is also one interface. So everywhere it will ask. See, we have to change all these, all dependencies we have to update. So if using abstract class, most of the time, second, what happened? Change visibility of this. Okay, so whenever we are in a different packages, okay, so if you create the constructor, make it as a public. If you want to provide the access to some other packages, we have to make it as public. If you don't make it as public, it is applicable up to that package only. Okay, so complete abstraction, full abstraction we can perform through interfaces. Okay, here interface concept will be started. Okay, there are some rules for interface. Okay, the similar rules only, whatever we have the rules for this abstract class, the same rules we have for the interface. What is the rule we have for abstract class? So we cannot create the object. Okay, for partial abstraction. For full abstraction also you cannot create the object. So along with that we have some more rules. Okay, so let me create one interface. First I'm creating the package. Okay, package name is interface. Okay, here some default package is already available with the name interface. Okay, so what I do is I create the package name as interface 1. Interface 1. So here, if you want to perform the full abstraction, okay, so we will take the help of interfaces instead of using the classes. Okay, to show the difference. Go to new, create. Now, so earlier we are choosing the option class. Now we have to choose the option interface. Okay, for interface to like to provide the specific feature. So we have one more block, that is interface. Okay, if you want to write a program, you have to choose any of these three options: class, enum, or interface. Okay, let's choose interface. Okay, so I'm writing the class name as full abstraction. Full abstraction. Okay, so in interface, if you want, here also you can, if you want to write some methods. Okay, so in abstraction also we have written few methods with body and without body. Okay, with implementation and without implementation. Similarly, in interface also we can create methods. We can create methods with body and without body again. Okay, so but without body methods you should create as instance methods. With body methods always, with body method always, with implementation only we have to create. Okay, so let me take the same examples from here. See, the same example I'm taking here. So let me remove this constructor. See, when you create the method with implementation, it is giving the error, right? For non-implemented methods, it is not giving the error. So if you want to implement the logic for your methods in interface, what you have to do is you have to create the static methods. Static methods. Okay, if you don't want to implement so it is a common. So you can create the abstract methods using abstract keyword. And also here in interface, by default, all the methods are public and abstract methods. Okay, let me remove these logics as of now. Let me create all unimplemented methods. Okay, so if you want to specify it is an abstract method, if you are not implementing, so generally we have to use abstract keyword. Okay, so here by default, all the methods, all abstract methods. Okay, yeah. So by default, all the methods, all instance methods. Okay, we should not call it as instance methods. Okay, all unimplemented methods are by default abstract and public. Again, no need to specify these keywords. No need to specify abstract and public keyword. But in abstract class, it is mandatory. Okay, suppose if you remove abstract keyword, you will get the error in abstract classes. But in interface, whatever the method you create, without implementation, all these are by default public and by default abstract methods. And also interface, before class we are specifying as a abstract keyword, right? Abstract class. But interface by default it is a abstract class. So to differentiate both abstract class, partial abstraction and full abstraction, they given the name as interface. Interface means it is a fully abstracted class. So for this also you cannot create the object. You cannot create the object. Okay, you can also write static methods. Okay, main method also a static, right? Main method also a static method that you can write. We have special methods. Okay, we have special methods. Default int method 1. Why it is showing error? Add return statement. Return some value. Okay, so default methods are generally you cannot create the object, and when you create the object or when you implement this class to some other child class, when you extend this interface to some other child class, that time you have to implement these methods, right? Again, so like we did here, we have to implement the unimplemented methods in our child class. Similarly, whenever you are extending interface to some child class, that time you have to again implement these methods, right? But coming to default methods, if you use the default keyword, you no need to again implement. You can implement the logic with the default methods if you want. In abstract class, you can directly create the implemented methods. You can directly write the implementation for methods, and also without implementation also you can write. But in interface, you have to write only unimplemented methods. If you want to write the implementation, either use static method or use the default method. Okay, but here the default methods you cannot call with the class name. So generally, if we have any static method, okay, so let me take, for example, let me create one more method which is a static method, static void method 2. So this is static method in interface. This is static method in interface. Okay, here this is also I write as a void. This is static method 2. This is instance method, right? Or default method. Default method 1 in interface. So now if I want to call method 2, I can directly call into the main method, right? Okay, if you run it, it displays this message. So to specify this method as a static method, generally we have to follow this notation, right? Class name we have to specify, then you can call variable or method. So now if I want to call method 1, how I can call? It is giving the error. You are unable to call method 1 default method. Okay, let me try with class name. Class name also I'm unable to call. See, so generally in interface, you cannot implement the methods. You cannot implement the instance methods. You cannot write the logic because this is for full abstraction. If you don't want to provide the logic, then go with the interface. But we have a option to write the implementation using default methods. Okay. So now what we have to do now? So let me create one more class. Now I am creating the class. Okay, again, if you create the interface, if you extend the full abstraction interface, again, you cannot implement the methods. Okay, so what it is, I will explain. Okay, so let me create the class access full abstraction. Okay, let me create main method also. Okay, here, if I want to access full abstraction interface, what I have to do? What I have to do? If I want to use the full abstraction interface, what I have to do? So we have to create the object. If you want to use any class interface or anything, you have to create the object for that, then only you can access. Because here we have instance methods. Whenever we create the object, that time only we can access those methods, right? That we are seeing from the first day. So here, if I want to like access this full abstraction, I'm unable to create the object, right? Because it is a interface which is having some unimplemented methods. You cannot create the object. Then how I can access the interface? So we have inheritance concept. Okay, you can generally, when you are using class, we are extending that class, right? We are extending that class. But here the one difference is, here you are not extending. You want to use the interface, right? You want to use the interface. In that case, generally, we don't extend. We don't extend. When we extend, if you want to add the some new logic, that time only you will extend the class. But you want to use the interface. So in this case, you have to use the implements keyword. Implements keyword. What is implements keyword? In full abstraction interface, you didn't implement the methods, logic for the methods. So here you are specifying that with your child class, you are implementing the interface methods. So that is the reason it is asking to add unimplemented methods, which means, so you are implementing. So the meaning of this keyword is we didn't implement the methods in full abstraction interface. I will implement methods in my child class. That is the meaning. Okay. So again, you cannot create the object to here. If you want, you can create the object for your child class. That you can upcast to full abstraction class. When you call full abstraction methods, suppose if I pass 10, 30. So we have methods dot addition. So if you want to print the result, just print with print statement. Okay. So like this, we can see. So 10 and 30, if I call addition, why it is showing 0, it is returning 0. So here you need to implement a plus b, subtraction a minus b. This is common logic. Nothing is new. Okay, but you are implementing in your child class, right? So what about default methods? Okay, if you want to call static method, how you can call? Using directly in other class also, you can directly call method 2. Okay, it prints method 2 also. I want to call the method 1. How I can call? So now you can use the reference. You can call the method 1. So that is the use of default methods. Generally in interface, we cannot write the implementation of the methods, but if you wantedly write some implementation, then use the default methods. Okay. So now what I do is, okay, let me remove public for this class. Public for this class. Create a class. Okay. So this is accessing. Okay. So let me do one thing. Here, this is a implementation, right? I will rename it as refactor and rename implement full abstraction class. Implement. Finish. Yeah. Okay, so full abstraction we have. Okay, let me remove these two also. Why to confuse you? Comment this, or let me do one thing. Commenting these three. So you have only unimplemented methods. Those you are implementing in your child class. But child class I made it as default, which means within this interface one package only you can access that class, this class. Okay, you cannot access outside. That we have discussed yesterday. Access modifiers. Let me create one more class. Access full abstraction or access interface. Access interface. Finish it. Okay, so here just extend. It is extends implementation of full abstraction. Nothing you write here. Okay, so let me create a jar file now. Okay, let me create jar file like we did in the previous class. So before that, what I do is, so here let me create one class. Okay, use interface. Use interface. Here I create a main method. So now where is my interface? I want to use the interface. Where is my interface? So full abstraction is my interface, right? Full abstraction that is imported. Interface one dot full abstraction. You cannot create the object, right? You cannot create the object because it is an interface you cannot create. If you go to this class, implementation class, for this you can create an object. It is fully implemented, right? Okay, go to interface and try to call this class. Try to create the object for fully implementation class. You cannot create because the scope of this class is up to this package only. It cannot be accessed outside. Now what you can do, so in this class is extended by some other class, right? So this class you can access because it is a public. For this you can create the object. Okay, so it is asking to import that class just from that package. Importing means you are fetching to your package like this, like some other classes. Okay, but this will not be imported because it is not a public class. These two will be imported to your package, then you can use those classes. Okay, now if you call the addition method, Yeah, you can call. Suppose if you pass 30, 40. So generally what happens is, okay, so that I will explain later. So now you are able to access. So generally what happens is, if you implement some logic, okay, if you implement some logic, generally where you have implemented, these are my logics, right? These are my logics I have implemented in the class. So if you want to share this logic with someone to use this logic, while sharing, you will share full abstraction, full abstraction interface with source code. With source code means this logic also you will share. This access interface class, this also you will share directly with code. But implementation full abstraction is there, right? This class you will share only dot class file. Only dot class file you will share. When they open that dot class file, they cannot see any logic, right? They cannot read also properly. Okay, but when they open this full abstraction, they can see the methods, but they cannot see the logic. If they go to access interface, they cannot see anything. Okay, so now let me create jar file, then you will understand. So the same methods I'm copying. Okay, so let me create as, let me paste it, calculator, calculator or interface, calculator interface. So let me implement calculator. Implement calculator interface. And provide the access to calculator interface. Access calculator interface. Okay, so let me change. So here calculator interface. This is my calculator interface. So let me remove these now as of now. And next implement calculator interface. So this should implement which one? Calculator interface. Okay. It has to implement calculator interface and access calculator interface. This is also should extend implement calculator interface. Okay, so let me export. Let me create a jar file. Jar file, select jar file next. Okay, here, why it is showing error? Any error we have? No, right? Okay, no problem. So here sources, this is the interface. I want to only share, remove this. Yeah, these three classes only I want to share. So here you will have one option, export Java source file and resources. Export Java source file and resources. Okay. So here we have some other, let me open. For each one also we'll have export refactoring or checked projects, generate class files and resources. This is fine. So Java source if you want to share, so you will give the access only for access calculator interface, and calculator interface only you will give. So for that you should get one option. Let me try to Okay, what I do is I will go to my src folder. Yeah. So in project src folder, I will go. Let me go to for project explorer, show in system explorer. So this is my project, right? So inside that in src, so we have created interface. So here this Java calculator implement full abstract implement calculator interface I am deleting now. Delete. Okay. But if you go to bin folder, you will have bin folder. Where is bin folder? So inside the bin folder interface, still you have implement calculator interface dot class. Okay. So now I will export the files. So not all packages. Just I want to. What is this setting? Okay. Just interface. Okay, these three classes only we require. Source also I will pass. Export all output follower for checked project token not required. Source also I want to share. Okay, so let's finish. Let me remove this implement calculator interface. Let's try like this. Okay, so no, let me change the name as calculator. 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 You can't finish. Okay, so now I have created one jar file here. Calculator. Okay, so let me import that. So right click, go to build path, configure build path, and click on class path, add jars. So add jars, it will directly go to this project explorer, add from external jars on desktop, calculator is there, open it, apply and close. Okay, so here it comes into reference libraries in interface. Okay, if you open this access calculator interface, so now let me remove these calculator interface again. Okay, so from here I have removed because we have these classes in we have in C. From here I'm opening the class files, but you are able to see the code. Okay, you are able to see the code from the jar file. See, these I have removed from here. See, this is the reference library. Okay, so from the reference library, okay, you want to access calculator interface. If you go here, you are unable to see any code for each method. In access calculator interface, nothing is there. Okay, so let's access this calculator interface. Let's use this calculator interface. Okay, let me create one new class, that is use calculator interface. Write a main method, Now, so here, this I want to, okay, here what I do is I create calculate interface object reference. You cannot create the object for your calculate interface. If you want to use it, what you have to do? You have to create the object for its child class, where it is access calculator interface. Access calculator interface. Okay, so here why we are getting the error? Access calculator interface only, right? Add cost to calculator interface. No. So interface one only, calculator interface, this is fine. Okay. Change type to, no, here also you will get the error. Okay, let me try to access methods. Dot addition if you call. Okay. Let me call addition method. Ten and 30. I think some issue is there. It is showing what it is. Data access configure build path. Why build path? It is already configured, right? Java build path it is already configured, but still why you are getting the issue? And close. So it's due to like I have removed that class, right? That is the reason we are getting the issue. I got it. While exporting the package, so we have to only export. We have to only export .class files. Okay, sources also we can include, but yeah, it is unable to identify that class. Okay, let me cancel it. Okay, so what I do is, so let me remove this from the build path. Okay, use calculator. So why here we are getting the issue? Okay, so this one is not available now. That is the reason the package is not available now. That is the reason we are getting the issue. So let me create again. Let me create jar file. So here something is missing. Okay, what I have to do again, I have to copy and paste these classes. Okay, so to understand, so here why it is showing access. This is also not required here. Yeah, let me copy it and before that full abstraction I rename it as, I mean paste it. It is a calculator. Calculator you have. Remove these. This is the calculator. So implement the calculator. We already implemented and paste it. Implement calculator. In implement calculator, it should extend calculator. Access calculator. One more class is access calculator. Access calculator. So you have three classes now. So again, let me export as a jar. So last time we removed the class file, export it, jar. So from the project, I want to use interface, not all classes, only calculator. Here the source code Java files if we pass, okay, so it should not take the implementation calculator source code. For that we used to get some option, but I'm unable to find here. Once we click on this, so we should get two options, .java and .class files. It used to show, but I'm not sure why it is only uh, giving the access for source code. Okay, let me export everything. So export generate class files and resources, that is fine. Export all out, nothing required. Export Java source files and resources. Okay, what is this? Not required. Cancel it. So we should get one option to export the .class files and .java files. For that also we used to get some separate option. It is not showing, but as of now, I will add direct entries, compress the content, overwrite existing files without warning. Okay, click on next. Export class files. Okay, this is fine. Warnings. Click on next. Save the, okay, no. Existing manifest workspace, no. Seal the jar, nothing. Seal some package details. No. We should have one more option basically. Okay, calculator jar only. This is fine, but yeah, let's see. Otherwise, you can do one thing. You can remove the sources instead of. So basically, sources if you provide, they just can see the your code. But logic if you share, again there will be no meaning of interface. Okay, so let me import that jar. Let's see what's happening. Go to build path, configure it. So in the library section, select class path. Okay, so in the library section, add external jar, calculator, open it, apply and close. Let's see whether you are able to see the code of implementation class. See, it is still showing. Let me remove, close all. Still it is showing the entire code. This should not happen basically. We should not do like this. Okay, what I do is remove it. I just give the only sources. Okay, sources only I will give. So again, I'm creating the jar file. This time I will just give the access to my class files. So here we have one more option, runnable jar. What it is? Extract required libraries and generated jar. Package required libraries into generated jar. Copy, no, not this one. Some like new changes happened, I think. So those I need to check. Okay, only how to export only required Java files. How to export only dot class files of some Java files. How to do, I will explain. I will check and I will explain. Okay, so I'm creating the jar file. I'm just providing the access to my class files. Okay, if they open the class file, they cannot see anything. Just click on finish. Yeah, I've override it. So now this calculator is a public, right? This I remove. If you remove it, you cannot access outside the package. implement calculator, it is anyway default. This is also I will rename it as default because I have to explain one more concept from this. That is the reason I'm still keeping here. Okay, if I want to access these class files, I cannot access outside of this package, right? So here, use calculator. I want to use the where it is build path. I have added calculator or not. So let me go class path, add jars, calculator, open it up, apply and close. Okay. I want to use my calculator interface from this package jar file. So let's create the object first. Calculator, calculator, calc equals to new. So you cannot create the object for your calculator. What you have to do? Access calculator. Access calculator class, you can create the object. Why it is showing? So it should be, okay. So here also we have the same classes, right? So that is the reason we are getting the issue. The interface package name also same and also package name same, right? So by default, it gives the priority to the internal packages instead of external packages. So here we have to remove or rename the classes. Okay, what I do is just refactor, rename one, putting as one, finish, finish. Again one, finish and finish. Implementation calculator. So rename, finish. Okay, so this I will remove. Okay, so now calculator import it from the package. Okay, so why we are not able to access this? Okay, calculator. Yeah, calc. No access calculator. Yeah, why it is showing error again? Cannot convert from access calculator to calculator. That is fine, but let's see. Did I do any mistake? Oh, access. That's what we did the mistake. Yeah, it is wasting the time. It is wasting literally time. Okay, so I need to like again create the jar whenever I copy. So I need to these update these classes. Okay, but I forgot it. Here I have updated access calculator. I have to update. That is the reason we are getting the issue here. So let me rename and again create the jar. Finish, finish it. So before that, let me remove from the build path. So now we have calculator, access calculator. I rename it. Finish it. And implement calculator also I'm renaming it. Finish. So here, which one I have to, first I have a calculator. Calculator I'm implementing. That is fine. And access calculator, what you have to do? From implement calculator, I have to do. Okay, so this should be public because otherwise you cannot access it. Calculator class also should be public. I mean, interface also should be public, otherwise you cannot access. And implement calculator, it should not be public because you should not give the access to this class. Now create the jar file, export it as a jar. Next, so from this project I want to export only this particular interface, only 3 classes. Okay, I want to share only source files. I want to create as a jar. It will override the existing one. So now let me add that calculator to my project. In the class path, add external jar, select calculator jar file, apply and close. So now calculator is available and you can see all dot class files. If you open any class file, you can see only some information, right? So let me do one thing. Yeah. So now I want to access this interface. Okay, where we are accessing use access, data access. So here use interface or use calculator interface. Okay, calculator now it is not giving any error. Okay, now if you call addition method, you can simply call it, but you cannot see the logic of your class. See it 10 comma some 40 comma 40. The same thing, whatever we discussed in the last class, the same thing we are performing with the interface. Okay, if you call it, it prints the 80. Suppose from where we are calling, if you want to access addition method, okay, it is there in the calculator class. So let me close it. See, if you go to use calculator, okay, if you check where this is calculator is available. Okay. So here these classes it is directly taking. Let me remove these classes. Delete it, and delete it. So now these classes are taken from the package. If you go to addition method, you cannot see logic. But here there are some methods you can see. Logic is not there, right? Logic is not there. If you click on addition method, it is showing this particular interface, but logic is not there. Suppose if you go to access calculator class, here nothing is there. You cannot see any method also. And this implementation calculator, how you will go? You cannot go again because access you didn't provide for this. And also you are not, you cannot create the object for your implementation calculator. Okay. For your implementation calculator, you cannot create the object because it is a non-public class. Like this, we will hide the data. We will hide the logic. We will give the access to calculator. Okay. So here, see, addition method. When you are providing just access to addition method, so you have to like provide some information about the addition method, right? What it does. Okay. So if you blindly like create some, if you create some logics, okay, if you don't give any description about this logic, how they will use. Okay. So if you want to provide some, description about the logic, okay, how to use that logic, we have Java docs. Generally for interfaces only, we put the description because they cannot see the logic, right? So at least by looking at the description, they can understand that, okay, if you use this method, this will do some operation. What operation it will do, you have to explain here, not logic. Okay. So if you want to add some description, what you have to do is, so Alt Shift J is the shortcut. Control Z, click on the method, press Alt Shift J, which is a shortcut to generate the Java docs. Java doc means it gives the information about that particular operation. What you have to do is, you can write this method performs, this method performs addition operation on input data. Okay, so parameters A and B you should pass like that. So let me create Java docs for all other methods. So now what I do is, on the input data. So these are the coding standards. Okay, everyone has to follow when they are creating the interface. Subtraction operation. This is the, what is addition? Okay, we have addition. Okay, this is subtraction and this is multiplication. This is multiplication. Similarly, you have division. Because sometimes we put some other name, right? Some random name we give. If you don't provide the, generally we have to use the meaningful name. Even though you provide meaningful name, they cannot understand what is division like that. Okay, if you give the description by looking at it, okay, so we have to, so this will perform division operation. Okay, if you want to use it for division, we can use it like that. Okay, so this interface only will do that. Okay, so let me again copy this and I will create calculator interface. This I will remove again. So paste it. It is a calculator. Okay, this is the calculator. Implement the calculator. Just again copy and paste. Paste. Cancel. This is copy and paste. Implement calculator. And also access calculator. Copy it. If you want to understand the further topics, okay, so you must concentrate on this. Okay, so what is this also I will explain later. What is this? By default it is giving rate. Tomorrow we will discuss it. So this is the implementation calculator, right? So it is a calculator. It should be calculator. Go to calculator. So remove unnecessary code from here. Okay, so whenever you write anything, that should be very neat and clear. Need to understand and need to, it should be in the readable format. Okay, access calculator, which is implementing calculator. Okay, so let me create the jar file. Okay, so this I remove. Go to build path, remove build path, and also I delete from here, shift delete. Now I create a jar file again, export it, jar, then interface, only calculator I require, access interface remove, full abstraction remove, implement full abstraction. I want only share these files, Java files. So we have one more thing here. What is this setting? Let me, settings here also it is not showing. you should get one more option basically. Class path is fine. Okay, let it be. So interface only we will. Okay, so finish. This calculator is already existed. Okay, if it is has, then override it. Okay, so here this is created the calculator check. Okay, this is the calculator. So now let me add that calculator to our project to use to show the difference. Add additional jar files, then calculator. By mistake, I have removed this one. That is the reason it is showing error. Okay, calculator is there now. Okay, you have calculator here. Okay, if you open it, you cannot see. So now if you go to calculation interface, why this one access calculator here. Okay, here AC only I have used. Import from this prefix one. Remove these files. By default, it takes the files from the internal packages. If those are not available, then it will look for the external packages. Okay. So now, if you want to use addition method, okay, similar way in the calculation, right? Calculation dot. If you put the dot, it is showing all the methods, available methods, right? Again, if you put the cursor, okay, so or if you if you want to use this, if you put the cursor here, the element neither has attached to source nor attached to Java doc, and hence no Java doc could be found. Okay, Java doc also we have to export. That I have missed it again. Okay, so no problem. So here you will get the description. When you put the cursor, here it is showing the description. Some window, yellow color window it is showing, right? So here, whatever the description we provided, that description it displays here, that Java doc. While exporting, I have to do that, but I missed it. Okay, while exporting, I have to select that option. I missed it. That is the reason it is not showing the description. So let me open calculator interface, whether we are getting here also it is not showing the Java doc. Okay, while exporting only I have to do that, but I missed it. Okay, so this much code quality you have to maintain while writing the code. Okay, so this Java doc again I will explain. Okay, like we are wasting more time. We'll move to the next topic. So interface also is like a full abstraction. If you don't want to share your logic, then create the interface, create a subclass for it, implement the methods, and provide the access for create one more class. Just give the access to interface and the final child class. Okay, so this implementation class you will not share as a logic, you will share as a class file. Okay, so we have few conditions in interface. We have few conditions. Conditions means when you create the interface, okay, suppose if you declare any value means suppose int a equals to 100. Okay, by default this variable is public, static, and final. Suppose let me create main method here. Okay, this is a static method, right? In static method, what we can access only static members, right? Suppose let me print a. If it is giving the access means, which means it is static. Okay, So whenever we are accessing anything directly to your static method, which means it is a static data. See, it will print 100. So it is by default, it is public. Even though you specify or don't specify, it is public and static. How you can say whether it is a public or static? Come to use interface. So here, if you are able to access that particular A, okay, which means that is public. So you can full abstraction dot A means if you are able to access means it is a public. See, outside package also you are able to access A, which means it is a public variable. But by default, it is also final variable. It is public, static, final variable. By default, whatever you create, that data is a final data. Okay, final data. So what is the problem with the final data? If you want to change it, if you want to update to 200, that you cannot update. See, you are getting the error. Okay, so even though you define with like this or this is the public static final. Okay, you cannot modify the data in our class or any other class. Yeah. And one more thing, you can create one more interface, interface 2. If you want, you can extend your full abstraction to your, what is the full abstraction, right? Full abstraction. So see, by mistake I created the class. I have to create the interface. Okay, so I can create the one more interface. Okay, interface 2. And in this interface, I can extend another interface. Which interface? Full abstraction interface. Okay, now I want to create one method, int mod division, which is accepting two values, A and B. This I don't want to implement. For this also, I create the Java doc. This is implemented. This is interface 2 is extending full abstraction. Okay, what is the extension? Extension meaning we are adding the new logic, but that also I don't want to. That also I don't want to implement. Okay, that also I don't want to implement. So you can directly extend the full interface to implement abstraction. Okay, so mission method again you have to implement here. Add an implemented method, mod division, return A percentile B. Okay, this is one type. If you don't provide the extension here, sorry, not here. Okay, not here. Here. So this is full implementation class, right? Okay. So now make it as full abstraction. These methods are there, but coming to this method, what you can do is you can again implement one more interface, that is interface 2. At a time, you can implement the two interfaces into your implemented class. So this is the reason. Okay, here what we are doing, somebody tell me what we are doing here. We are implementing full abstraction, and also we are implementing interface 2 at a time. From two interfaces we are fetching the data to my class. If I create object for my class, I can access both the interfaces methods, right? Both the interfaces methods. Implement full abstraction. So I can access with the single object. I am getting two classes or two interfaces data. And also with this, you can access mod division also. At a time, you are able to access the data. Okay. So this is called multiple inheritance. Multiple inheritance. So at a time, you are getting the data from two classes to a single class. So class or interface, two interfaces from a single class. Okay, this is interface 1 and this is interface 2. This is class. Or you can extend more than one class also into some other interface. Let me create one more interface. New interface, interface 3, interface 3, finish it. Extends full abstraction interface, comma, interface 3, interface 2 also. Okay, here one more interface you are interface 3. So here, why it is giving the access to create for classes, we don't have this option. Why? So whenever we extend more than one class, okay, so your JVM will confuse. Okay, so in classes we will have implemented methods, right? Implemented methods. So if we have same methods in both the classes, that time it will confuse to call the methods. From which method I need to call, it will confuse if we have the fully implemented methods in the classes. But whenever we are using interfaces, that time it won't confuse, because even though it goes into that particular interface, that logic will not be executed from there, right? From the child class only it will execute. If you call from the interface 1 or interface 2 or interface 3, again it will call from the child class only, implementation class only. In the implementation class, we will have only one method. So in that case, it won't confuse. So if you want to extend more than one class, that is not possible directly. You have to create the interface. So interfaces, multiple interfaces, n number of interfaces one by one, you can create and you can access through the interface 3. Suppose this interface 3, inside that, okay, let me write one method, int factorial of a number. Factorial of a number. Suppose it is accessing some a. Factorial. Return. Okay, so we should not create the body for unimplemented methods. So now extend this interface into implementation class. Implementation class. Okay, this also you can put like this, or you can directly implement the interface 3. Interface 3 already extended by interface 1 and interface 2. Implement the factorial method. In this factorial method, write some logic. Okay, what we have to write? Some int fact val equals to 0. Construct a for loop for int I equals to 0, I less than or equals to a, I plus plus. So here fact equals to fact into I. This is the logic, right? Fact val equals to fact val into I. So this is the factorial logic. So return that value. Okay, now you can create the object and you can access all these from, you can access all these methods from this object, or you can extend this class to some other class, provide the access. Okay, so here one more thing. Okay, so let me create one class, new class. So here I'm creating the name as class 1. Finish it. So inside the class 1, what I'm doing is I can create one method. Method name is just void display, just a display method. Some method is there. So here I'm writing some, this is display method, display method of class 1. Okay. So if you want to extend this class to your implementation class, that is also possible. Okay. At a time, you can extend one class and you can implement more than one class. Okay. So here extends class 1 and implements. Okay. So from 3, I remove these extends. So here in implementation class, what I do is I use all these 3 here. Okay, this is also possible. You can extend one class and implement more than one interface, but extend only one class. You cannot extend more than one class. Suppose if you create the class 2, you cannot put the comma and class 2 you cannot put. Okay, so these are the rules we have. Okay, more than one interface you can perform the implementation, because if it is goes to the interfaces, it cannot call the logic, right? It has to call the logic from this the implemented class only. There will be no confusion for the JVM. There will be only one class finally. Okay. Yeah. So here in class 1, if you have some existing method, that will be overridden. Suppose if you maintain the same methods in class 1, those will be overridden by the implementation class. That is the common thing. Okay. That is the common thing. So remove override. It will go the error. Okay. These are the old logics like that you can consider. These are the new logics like that you can consider. Okay. So see, if you understand this well, then only you can understand the next topics. Okay. If you don't understand it, immediately go through the recording again. Okay. I will update in half an hour or 1 hour. I will notify you through WhatsApp. If you don't understand it, okay, again watch 2 or 3 times. Then you will understand. Again, these all things are connected in the previous video. I mean, in the previous class. Okay, if you don't understand this, again, you have to watch the abstraction related, partial abstraction related. class. Okay. Yeah. So do practice. Let me stop recording.